Moon. This familiar object in the night sky has inspired the imagination to count time. In modern times, Moon, the only natural satellite of the Earth, has a that Moon is the key to our understanding of the evolution of the solar system. Resources and low gravity have further endeared it to humans. India, a major spacefaring nation, has conducted a detailed exploration of the Moon through its Chandrayaan program. The country has sent 2 robotic spacecraft to orbit the Moon and to take a repeated look at its surface. Chandrayaan-1 demonstrated India's ability to reach the surface of the Moon at a place and time of its choice. And with it, India became the 4th country to reach the surface of the Moon in November 2008. Besides, Chandrayaan-1's conclusive discovery of water on the Moon in 2009 was praised as a heartbreaking discovery. The follow-on mission, Chandrayaan-2, had an orbiter, a lander called Vikram, and a rover named Pragya. In the past 4 years, the orbiter has repeatedly observed the lunar surface and even today is working satisfactorily. Now, 3,900 kilograms Chandrayaan-3 spacecraft is being sent to the Moon with the objective of making yet another focused attempt to slowly land on the lunar surface and to explore it with the help of Chandrayaan-2 had an orbiter, a lander called Vikram, and a rover named Pragya. In the past 4 years, the orbiter has repeatedly observed the lunar surface and even today is being sent to the Moon with the objective of making yet another focused attempt to slowly land on the lunar surface and to explore it with the help of a rover. Following the spacecraft launched by India's most capable rocket, LVM-3, the Chandrayaan-3 lander carrying a rover within it will be carried into an orbit around the Moon by the propulsion module. A little later, the lander will separate from that module and will attempt to make a soft landing in the south polar region of the Moon. This region is of intense interest as it has many permanently shadowed craters which could contain water ice and precious minerals. Chandrayaan-3 lander has 4 scientific instruments or payloads, of which one will study the moonquakes, while the other one studies as to how the surface of the Moon allows heat to flow through it. The third one will study the plasma environment near the Moon's surface. And the 4th instrument will enable scientists to measure the distance between the Earth and Moon very accurately. The 2 instruments on the rover help us study the composition of the Moon's surface using X-rays and laser to spectate. While the lander and rover will be in direct contact with each other. The propulsion module circling the Moon will observe the light coming from Earth, the only planet which we know which is definitely teeming with life. This observation will help in understanding the nature of distant planets circling stars other than the Sun. As Chandrayaan-3 undergoes important tests and years up for launch, thousands of ISRO scientists, including those who will launch it, control it, and receive the precious scientific information from it using giant dish antennas, are readying themselves for the challenging tasks ahead. In the past, their dedication and skill have enabled India to earn praise from across the world and made it proud.
के लूनार मिशंस का विवरण। अब चलते हैं towards Chandrayaan-3, the follow-up mission of Chandrayaan-2, which has been designed to accomplish our mission goals. The primary objective of Chandrayaan-3 mission is the demonstration of safe and soft landing on the lunar surface. This demonstration is a critical aspect for ISRO's future interplanetary missions. In addition to this, the mission objectives also include demonstration of roving capability and conduction of in situ scientific experiments on Moon's surface. Carried on the shoulders of India's heaviest rocket LVM-3 on the 14th of July, Chandrayaan-3 was placed in the precise elliptic parking orbit of size 170 by 36,500 kilometers. ISRO, in its mission plan of 5 earthbound maneuvers. The fifth apogee raising maneuver, which took place on the 25th of July, placed the spacecraft in an orbit of
7.4 किलोमीटर कर दिया जाएगा। इस पूरी प्रक्रिया को पूरा करने में लगभग 11.5 मिनट लगेगा और इसका समानांतर वेग 1680 मीटर प्रति सेकंड से घटाकर 358 मीटर प्रति सेकंड हो जाएगा।
We have continuous flow of lander telemetry data from ISRO's Deep Space Network IDSM-32 located in Velalu, Bengaluru. The data is being acquired real time by station and is flown to the mission operation complex through our communication links. In addition to it, the event had started 48 hours before, wherein various pre-selections and uplinking of parameters for the autonomous landing sequence were carried out. The whole descent is divided into 4 phases: the rough braking phase, the attitude hold phase, fine braking phase, and the local navigation phase or the terminal descent phase.
एक बहुत ही महत्वपूर्ण फेज है। इस 10 सेकंड के स्मॉल ड्यूरेशन के दौरान लैंडर के 2 महत्वपूर्ण सेंसर कारा और लासा लैंडर की ऊंचाई की गणना करेंगे। इस फेज के पूरा होते ही लैंडर चंद्रमा के सतह से कुल 6.8 किलोमीटर की ऊंचाई पर होगा।
During the rough braking phase, the lander velocity shall be brought down from 1,680 meters per second to 358 meters per second. The altitude will be brought down. The mission is 7 kilometers, and the downrange that has to be traveled during this phase is 713.5 kilometers.
जी हाँ, अभी आप देख सकते हैं कि लैंडर की करीब आ चुके हैं।
The altitude is being brought down from 800 meters, and we are nearing and approaching the lunar surface. Vertical descent phase 2, which will have the lander module hovering